So what to do for definite integrals? What are definite integrals? Definite integrals are such integrals in which the lower limit and the upper limit is given. Okay, do you remember our graph where we studied? So when there is a limit which is given from this point to this point, in these questions we saw that there is no limit which is given. Okay, now suppose there is a limit which is given from 2 to 3. I want to integrate x dx from 2 to 3. Okay, so this lower one is known as lower limit and the upper one is known as upper limit. In this type of question, first you see what is the given value that I want to integrate. Just integrate it with our formula. So x to the power 1 is there. So what will be the integration? X plus, to the power 1 plus 1 by 1 plus 1. So answer will be x square upon 2. Now what to do with the limits? Just we will put it in square bracket. We'll write the lower limit down, upper limit up. Lower limit down, upper limit up. Now what to do? Once we have completed the integration, here we will not put any constant. Here no constant will be there. Why? Because we will directly find the exact value. What to do? First you put the upper limit in place of the variable. What is the variable? X. So in place of x, I'll put 3. So 3 square by 2 minus, we will put the lower limit. What is the lower limit? It is 2. So 2 square by 2. Now solve it. 2 and 2 common out, so here 9 and here 4, so 5 upon 2. Now why we are subtracting the upper limit minus lower limit? Why? Because we want to find the integration. Okay, suppose I want to find the integration from this to this. Okay, this area I want to find. So what I am doing is I am trying to find the whole for the area for this function, and then I am finding this function. So I want this much, so what I will do? Upper limit minus lower limit. So I'll get the area for this one, this much. Are you understanding? So this is the way we do definite integrals. Let us do another one. Suppose x square dx is there, okay, and I want to integrate it from 0 to 3. So what we will do? X square dx. What will be the answer? X to the power 2 plus 1 by 2 plus 1. So x to the power 3 by 3. And what are the limits? 0 to 3. So first I'll put upper limit. So 3 cube by 3, then I will put the lower limit, that is 0, 0 cube by 3. So here it will become 0, and here 3 3s are 9, 9 3s are 27. So 27 upon 3, that is 9. So 9 is the answer. Suppose the question is 1 by x dx and the limits are 2 to 5. Now when it is like this, 1 by x dx, this means what? X to the power minus 1. We have studied that x to the power minus 1 is not valid. So what is the formula? We studied the formula also. This we have to learn, okay, that 1 by x dx is log x. The integration of 1 by x dx is log x. Now what is the limit? It is 2 to 3. So what I will do? Upper limit in place of the variable I'll put x, then lower limit in place of the variable put 2. Since these are positive integers, so no need to put it mod. Okay, so now we know log subtraction. So what will be the answer? Log of 5 by 2. This is the answer. Okay, now suppose nothing is there, no variable is there, 1 is there. Okay, so 1 means what? X to the power 0 is there, then only 1 is coming. 1 means what? X to the power 0 is there. So when I will integrate this, x to the power 0 plus 1 by 0 plus 1 plus c. So x to the power 0 plus 1 is what? 1 by 1, 0 plus 1, 1, c. So answer is x. So whenever I am integrating dx, we are getting x. Okay, so whenever I am integrating dx, I'll get x as answer. Suppose I am integrating dt, what will be the answer? It will be t. Suppose I am integrating dy, so I will get y. That is okay. So integration means, suppose I am integrating small displacement ds, so I will get s, full displacement s. Okay, suppose here if it is given, limits are given, suppose 3 to 5. So what I will do? In place of s, I'll put 5 minus 3. So 2 is the displacement. Okay, in this way we will do. Let us see 2 more questions. Okay, suppose it is like this, 2x to the power 2 dx. Now 2 is a constant, it is not changing here with, see what is changing? Dx. So x is changing and nothing else is changing. So 2 will be constant which will come out. So 2 came out. So x squared dx is inside the bracket, inside the integrals. So x squared dx integration will be 2 plus 1 by 2 plus 1. So x cubed by 3. This 2 is here as it is. Plus, since it is no limits are given, so plus c. If it is 3 dx, see anything is there which is changing, 3 will come out. So here what is there? 1 dx. So 1 means x to the power 0, same case. So dx integration will be how much? X. So 3x plus c. In this way we will do. Now this was the first formula, and the second one was 1 by x dx is what? Log x. This much we have studied 2 formulas till now. So third one is, suppose if it is e to the power x dx, then integration of it will be same, e to the power x dx, and since no limits are given, so c. We have studied that differentiation of e to the power x dx was also e to the power x. Do you remember? Differentiation of e to the power x, it was e to the power x only. So integration of e to the power x is also e to the power x. Means exponential functions have no effects. Then sin x see, this one is very important. Sin x differentiation was cos x. But when I integrate sin x, see what I am getting? Minus cos x. In the same way, when I differentiate cos x, we used to get minus sin x, but here when I integrate cos x, I will get only sin x. This is the only important thing about trigonometric function. Okay, differentiation of sin x was cos x. Now integration of sin x is minus cos x. Differentiation of cos x was minus sin x, but it is sin x. In that way, other things are also working in the same way. Like differentiation of tan x was sec square x. So if I integrate sec square x dx, I will get 10x plus c. Differentiation of cosec x was minus cosec x cot x. So if I integrate cosec x cot x, I will get minus cosec x plus c, which is the just opposite of differentiation. Let us see algebra of integration. Means when two functions are added, then what will happen to the integration? Suppose I want to integrate this. Okay, suppose I want to integrate this with respect to dx. So what I am doing? Dx, and I want to integrate it, and here also I want to integrate it dx. So what will happen? I will just separately integrate it. The answer will be same. Okay, dx, first integrate this part, then you take this and integrate it separately. No problem. Okay, so dx, x squared dx is what? X to the power 3 upon 3. And 1 by x dx is what? Log x plus c. So like this we can do. Suppose there are 3 functions like that. If I want to integrate it dx, so what I'll do? I'll take this whole function and I'll integrate it dx. So okay, integrating it both the sides. So what I have to do is just separate it. E to the power x dx, integration of sin x dx, integration of root x dx. So e to the power x dx will give me e to the power x only, sin x dx will give me minus of cos x, and here root x means 1 by 2. So 1 by 2 plus 1 by 1 by 2 plus 1. Just solve it to get the answer. Okay, so this much is the answer. In the same way, if there is subtraction also, then also we would have done it in the similar way. Now multiplication, there is a rule. There is a huge rule on this. Let us not concentrate on everything. Just let us see one. UV. Okay, it is known as UV method. Okay, UV method. First thing is it will follow Eilert principle. Okay, I'll tell you about it later on. Suppose there are two functions u and v, and I want to multiply it, which is inside the integration. Okay, inside the integration. So what we will do is, first thing is we will take out u. We have seen differentiation of uv by dx gave me what? U into differentiation of v dx, and then plus v into differentiation of u dx. We used to do this. Now what to do for multiplication? So multiplication also one formula is there in the same way as it is there. Suppose it is like this. Okay, so u first I will take it out. Now integrate v dx over, then subtraction of, okay, first differentiate du upon dx. Okay, first differentiate du upon dx, then integrate dv upon dv into dx. Okay, then whole thing that I will get, I will multiply it, and whole thing that I will get, I will again integrate the whole thing. Okay, this is the formula of multiplication. And now what is Eilert principle? I stand for inverse function, L stand for logarithmic function, A stand for algebraic function, T for trigonometric, and E for exponential. No need to worry. Okay, when you will do the sums, it will be very easy. Now this principle means that here the v and u that we are selecting, whatever I am getting this first. Okay, suppose there is an inverse function, and suppose this is u is the inverse function and e is the exponential function. So I will take u as inverse, and suppose there is u is an algebraic function and v is an inverse function. So I will just make this as u and this as v. Okay, I'll just interchange it. One example, suppose x sin x. So no problem, x is what? Algebraic function, so it is coming first. Then sin x, that is trigonometric function. So it is coming afterwards. So it is correct. This will be our u and this will be our v. Now we will apply the formula. Just keep u as it is. Integrate this. So integrate this. Now whole integration of, first differentiate dx, so dx upon dx, then integrate this, so integrate this, and whole integration. So x as it is, integration of this will become minus cos x, minus of dx upon dx will be 1 multiplied with whatever I am getting here. So integration of sin x is minus cos x into dx, minus sign will come out, so minus minus plus. So here one minus is there, minus x cos x first term, then second term here plus, and here integration of cos x, plus integration of cos x will be how much? Sin x. So this is our answer. In this way, suppose x and e to the power x. Again, this is algebraic, this is exponential. Let us check. First which will come? First algebraic will come, then exponential. Means this is our u and this is our v. Okay. Suppose it would be like this, e to the power x into dx. Now integrate it. So I cannot make it as u and this one v. I have to check it by Euler principle. Then I'll make it as x, then e to the power x dx. Then I will integrate it. Then only my answer will be correct. Otherwise it will be wrong. Okay. So we will choose by ourselves what is u and what is v. The last thing is chain rule. As we have studied in differentiation, here also it is there. Suppose sin 2x is there. Now if sin x would be there, easily I could have integrated it to minus cos x. But sin 2x is there. So first I will integrate it, cos 2x. Then whatever is here, okay, this one we will differentiate. Okay, not integrate, differentiate. So this 2x differentiation is what? 2. So we will write 2. Are you understanding? And since it is not definite, so it is C. Once again, see, suppose this one, e to the power 4x dx. We know that e to the power x, integration of e to the power x dx is e to the power x. But here it is 4 is there. Then what to do? So first whatever is there, first I will integrate it. So e to the power 4x. Then whatever is inside this variable, okay, dx, here is that 4x. So again differentiate it. How much I am getting? 4. So divide it with that much. Suppose cos x square plus 1 dx. Okay, so sin x, integration of cos x is sin x. So sin this much. Now differentiate it. So after differentiating it, how much I will get? 2x plus 0. So whatever I am getting, I will just divide it with that. Whatever I am getting after differentiation, I will divide it with that. Suppose sin x square plus e to the power x dx. So sin x integration is cos x. So as it is, I have written cos of this much. Then what we will do? We will differentiate this. So 2x plus differentiate of e to the power x, e to the power x itself. So divided by that. So 2x plus e to the power x. Okay, now here one thing we will remember, that there is no such u by v formula, no such division for integration. In integration there is no such division. Rather we have to do substitution method. What is substitution method? Now this is also easy. Suppose x by 1 plus x square. So if it would be a differentiation, we could have used u by v formula. But here no such u by v. Just take this as t. Okay. So after taking this as t, so it will be, let us differentiate it. So dt with respect to x. Okay. So dt upon dx will be how much? 1 differentiation is 0 and here 2x. So dt's value will be, dt is equals to, this will go up. So 2x into dx. So from here, if am I getting x dx value? X dx is how much? Dt by t. So here I can see that x dx is there. So in place of x dx, I am writing dt by 2. And 1 plus x I already assumed at t. So let us take it as t. So it is what? 1 by t dt, and this is 1 by 2. That is a constant. I can take it out. So 1 by t dt is log t, and half is as it is, plus c constant. Okay, so once we have completed the differentiation, integration, so we'll put the value of t. So whatever we have assumed, we have put it. So this is not that important. When you will study in integration, you are going to study all these things. But for now, you just remember one most important formula, that is y to the power, suppose y is equals to x to the power n, and if I want to integrate it with respect to dx, okay, so what I will get? X to the power n plus 1 by n plus 1. This is the most important one, and since there is no limit, so it is C. Okay.